I just don't know why I do the things I do. Great, great. All right, let's continue now. What page are we on? 52. True.
Yeah.
Right, so much in the same way as the last class, we're looking at how to solve equations that would have logs in them, or perhaps you would need to use logs to solve them. So before we even get into that, just a type of question that they sometimes have in the exam. Anyways, this is log equations. So for example, a common enough exam question would be something like this. The question might be something like, when is this log defined? So what they mean by that is, what are the values of x that you can legitimately use? Like, what values of x are allowed? Okay. So we all should remember that we cannot take the log of a negative number. So this requires that 2x plus 3 needs to be positive. Could it equal 0? What do you think? Yay or nay for that?
Yeah.
No, it can't equal 0. Remember, we said this, we can't have log of 0. Okay, so x is bigger than minus 3 over 2. So in other words, it's the set from minus 3 over 2 to infinity. Does anybody actually know what that set is called? The set of values that you can use. It has a name. I'm sure somebody knows it. No, close, but not this. The other one. Anyone know? No? No, I think... No. I'm sure somebody knows this.
I don't want to give you anything.
Go on, what do you think it is? No? Any ideas? No? Guys, I'm sure somebody knows this. Alright, fine. Domain.
Oh, yeah, domain.
Right, so write this example down, please. We'll have a look at another example now. Got that?
Why is this surrounded by the closed bracket? Before the negative 3 by 2, why is it a closed bracket?
Because it's not, couldn't equal minus 3 over 2. Because we don't want equals here.
Closed when it is equal.
Yeah. Right, do we have this one? Yeah. Okay, the next one now. I'll just make up my own example. Suppose I ask you to solve 2x equals 3. Now, it looks like we did something like this already in the last class. However, the method that we had in the last class doesn't work here, because we cannot change the 3 into a 2 with a power. You know, because last time I think we had something like 2 and 8. Yeah. Can't do that here. Now there's two ways to do this, and I want to show you both ways, because it depends on what calculator you have. So if you have the Casio 991, or a calculator like it, you realize your question is 2 to what power equals 3, which is exactly what the log is for. So the answer here is log base 2 of 3. However, if you don't have the option to change the base on your calculator, we can do it another way. Everybody will have the ln natural log button. So one way you can do this is you can put natural log on both sides. Yeah, and then what happens next here? The x comes down, yeah, so you have x natural log 2 equals log 3, and then x equals log 3 over log 2. And by the way, you realise that you could have gotten to this answer as well from the left, because if you did it this way and then realised I don't have base 2 on my calculator, then you change the base. So you say this will be log base e of 3 over log base e of 2, which in fact is the same answer. So there's like 3 ways you can do this, whichever your calculator is suited for. And this of course will be a decimal. What will it be, like 0? What is it? 1.58. So if you can write these 2 methods down, it'd be great. Got that? Yep. So, next example now. Okay, so this one is similar to what I just did, a little bit trickier. 2 power 8x minus 4 equals 5 power x plus 9. So this one here, again, we have to use logs by putting log on both sides here. We can bring the power down. So we have 8x minus 4 log 2 equals x plus 9 log 5. Yeah? It is. So, next, yeah?
What difference does it make with natural log or normal log?
Doesn't, well, I wouldn't call it normal log firstly. It doesn't, in fact, you can use any base.
Okay.
So if you use base 10, same answer in the end. Okay. Right, we'll expand now. So this is 8 log 2 of x minus 4 log 2 equals log 5 of x, not of x, times x, plus 9 log 5. Well, we'll just take our x's to the left. 8 log 2 of x minus log 5 of x, and then we'll take the 4 log 2 to the right. 4 log 2 plus 9 log 5. So 8 log 2 times x minus log 5 times x equals 4 log 2 plus 9 log 5. It's just a bit of algebra, moving things left and right. And you realise on the left, well, we have an x and we have an x, so take them out. 8 log 2 minus log 5 times x equals 4 log 2 plus 9 log 5. And then you realise, oh, well, there's only one thing left to do, which is divide. So you get x equals 4 log 2 plus 9 log 5 over 8 log 2 minus log 5, which will be a decimal. Let's see. Uh, 0.699, I think. Okay, write this one down. I should point out, this is a very common exam question on logs. This one here.
Normal log has base of 10, yeah.
Don't call it normal log.
Whichever.
The default on the calculator, LOG, is base 10.
Because I don't think mine has that many logs. I could put it in, but like I can't find
You
it.
can use any log here, actually. You'll get the same answer. We got this? Yeah, it's okay. Yeah. Okay. Now the next one I have to do is kind of similar to something I did yesterday as well. Let's have a look here. Yeah. Yeah. Question? No?
I'm getting x is 4.3.
It's not this, sorry. Okay, what is it? 4 point. Okay, thank you. Right, next example. Let's see. We'll have 2e 2x minus 7ex plus 3 equals 0. Right, this is another common one for the exam. So, I think we can all spot what type of equation this is. What type is this? It's quadratic, isn't it? Where ex is the variable. No, the real question is, can I factorize this, or do I need to use the formula? I don't think I can. Oh no, wait. Yeah, maybe 2ex 3 ex minus minus. Is that possibly right? I believe that will do it, won't it? Oh, so, well, of course, I mean to write 1 here. Yep. Right, well, that's good, because that gives us ex equals a half, and ex equals 3. Right, so that means x equals log a half, and x equals log 3.
But how do you get 7ex out of 1 and 3? That'll be
2 times 3?
okay.
Enough said?
That's it.
Yeah. This is also a common exam question. My experience is that they usually make it have factors.
Can we with factors that don't have the same denominator?
Say again?
Can we do one with factors that don't have the same denominator?
What do you mean?
So like x to 7 over 9 is equal to x to the power of like 2 over 3 or something. Like just not the same denominator on the power.
Give me an example question. You can make one up. No, make one up if you have something in mind.
I don't have something in mind, but let's say minus 8x to the power of minus 9 over 5 is equal to minus 3x to the power of 7 over 6, which is both different denominators to the power.
Okay.
But different bases, right?
Yeah.
This is from the last lesson, is it?
Yeah.
I don't see how that's very different to what I did.
You just log.
No need for logs. Huh? Yeah, well look, just briefly Mo, here, this is x 7 over 6 over x minus 9 over 5. If I bring that down, equals 8 over 3.
Yeah.
Yeah.
Yeah. 7 6 plus 9 fifths, goodness, what's that? 7 6 plus 9 fifths, that's 35 plus 54, so 89 over 30, is it?
Yeah.
Yeah, I shouldn't have been similar to your calculator in time. 89 over 30 equals 8 over 3. Well, actually, do you know what? Will we use logs to solve this? Or you don't mind? Because you have two ways to go here.
Yeah.
If you can go the log route or the non-log. So if you use the non-log, you would have x power 89 over 30 equals 8 over 3. And what you would need to do is put a power on both sides of 30 over 89. Because then they cancel. So you end up with x equals 8 over 3 power 30 over 89. But if you want, you can take the log route. So here, if you have x 89 over 30 equals 8 over 3, you can put a log on both sides instead to cancel. So log and log here. So then you get 89 over 30 log x equals log 8 over 3. So then you can get log x equals log 8 over 3 over 89 over 30. And you're nearly finished, you just need to bring it back to x. Does anyone know how to cancel a log?
E?
Yeah. This is something I was going to mention for the next question, but since we're talking about it now, I'll mention it here. E log x equals what? No? X. And log e of x? No?
1.
X. Yeah. Because you can cancel e's with logs. So anyways, if I want to do the same thing here, I'll have to put an e and an e on both sides. So here you'll get x equals e power 30 over 89 log 8 over 3. And actually that will and should be the same as what you did on the right. You should get the same answer as typing in 8 over 3 power 30 over 89. Yeah?
Can you go back?
To which one?
The row, the E row.
Oh, on the left?
Yeah.
Yeah. Yeah, I'm just saying e and log and e cancel.
Can I have the time on that?
Okie dokie. 18. Can I scroll back?
No.
Yeah. Yeah. Okay. Right. Next example now. If you can just write this one down. You have two ways to do this. You don't have to write this one down, but if you found it useful, using the logs. We did this one yesterday without logs. And by the way, if you think about it, if these answers are supposed to be the same, then you need to be able to imagine how we can go from this answer to this answer.
The log thing is just very complicated.
Yeah. That's why you don't have to write it down.
What term is it?
I think it's 18.
Yeah, it was 18. I actually solved it this way. On my
With the logs?
Yeah, with the homework.
Okay. Continue.
Yeah.
Yeah. So look, next one now requires the rule I just showed you, if you want to call it a rule. 2 power minus 9x plus 4. So what I'm saying in this question is, it's always possible to write something like this in the form a, e, b, x for some a and b. Now, you might wonder why you would want to rewrite it. It's actually quite useful to have things written in this form when possible instead of this form here. So the question is, how can we write this on the left in the form of the right? Okay, so let's have a look here. First thing I'll do is I'll change this into 2 power 4, 2 power minus 9x. Now 2 power 4 is 16. So that's 16 times 2 power minus 9x. Now you can see it's starting to take shape. We can already imagine what the a probably is. Probably is going to end up being the 16, isn't it? Because it's looking like that's the number in front. But now our next problem is how can we deal with the 2, try to make it become an e. So what I'll do next, continuing here, is I think I'll just pull the minus 9 out. So that's 2 power x power minus 9, double power here. Because if you multiply x by minus 9, you can take it back to minus 9x. Now this is where the trick comes in. The 2 power x, I'll change that into e log 2 power x. So in other words, if I just put on the side here, just to make it a little bit clearer, 2 power x, or 2 power x, I change that into e log 2 power x. Now you might say, why can I do that? Well, e and log cancel, don't they? So if I can cancel e with log, what am I left with? 2 power x. So it actually is the same thing. 2 power x is the same thing as e log of 2 power x. And this is how I can get the e introduced into it. So, continuing now. This will be 16 e x log 2. Because what I've done now is, you can kind of use it in a different colour, use my rule of logs that says I can bring the x down in front. Okay, what is log 2? I think it's minus 0.69? Yeah, is that right, log ln2?
No, 0.6.
0.69. So that's 0.69x power minus 9. So the last thing to do is to multiply the 9 in. So can you just multiply that by 9? 0.69 6.24 if we round it off, is it? So you realise now you've written it in the form where this is the a and this is the b, in the a, e, b, x.
Should it be minus?
Oh, sorry, I lost the minus, thank you. Thank you, minus there. Yeah.
It isn't possible for you to take the minus 9 to 16.
No,
Why?
because it's not possible.
What about the rule where the raised power takes you back?
That's only if it's a log. Like, if I have log x minus 9, I can bring the minus 9 down. You know, but if I just have x minus 9, I can't just bring the minus 9 down. There's no, this isn't a log. This one. 24. Now, if you don't believe that this is actually the same thing, because, you know, I'm actually saying that 2 power minus 9x plus 4 is the same thing as 16e minus 6.24x. Well, you can test it out. If you put in the number 1, I'm saying that 2 to the power of minus 9 plus 4 is the same as 16 to the power of e minus 6.24. You get the same answer. So it is actually useful to change this into this form. One of the reasons why is that we don't really have a derivative of this, but when we study calculus later, we do have a derivative for e. Also, we're not quite sure what the graph is for this, but we're quite sure what the graph is for this. The graph for this would look exponentially decreasing, and it will cross here at 16. Well, there's some advantages to rewriting it. Okay, one more example to do here. Okay. Have we got this? Yeah. Right. Log base 3 of 1 over x cubed plus log base x of 81 equals minus 5. So for this problem, I'm trying to obviously solve for x. Before I even begin, I need to state what the domain is for x. What is the allowed values of x? So the problem really is here. What values of x can I not use? Definitely can't use 0. And what else?
1.
No, 1's okay.
Minus.
Yeah. Yeah. So if we can't use negatives and 0, then what we're saying is x must be positive in our answer. Yeah? Right, now we realize there's many problems here. The first one is that the bases are different. One base is 3 and the other base is x. That's one problem. Second problem is we have a 1 over x cubed. And actually the third problem is not everything is a log. You know, because you have a log, and a non-log. There's actually several problems here. So the first thing I'll actually do is I'll just change that x cubed to x to the minus 3. Like that. Okay, next what I'll do is I think I will bring down that minus 3. Like that. Are we okay with that? Also, I think I'll change that 81 as well. What could I change the 81 into?
3 to the power of
3, 4, isn't it?
Yeah.
So that's log x 3, 4. Okay, you can kind of see what probably is going to happen next.
4 on.
Yeah, the 4 comes out. Okay, good. We're slowly chipping away at this and making it simpler. What should I do next?
Change the 1 by
Yeah, change the base. Now, which rule?
1
The 1 over, yeah, the swap around rule. So this will be minus 3 log 3x plus 4 over log 3x equals minus 5. Right, now, what to do next?
You need to make the minus 5 log. So minus 5.
Yeah, actually, at the very beginning, I thought I might have to do that, but I don't think I do, actually. Yeah.
Yes.
The 4 over log 3x isn't it the same thing? Minus 4 log 3x.
Minus 4 log 3x.
Yeah.
It's not, I'm afraid.
That's saying 4 times log 3x raised to the power minus 1.
Yeah, but unfortunately, when you have it like a -1 like this, that -1 doesn't come down. Yeah, it only comes down if it's on the tree, not on the whole thing. Okay, what should I do next here? No combining just yet. Yeah, you have two choices. You can use a substitution, but what I'll do is it's similar. I'll just multiply everything by log 3x. So if I multiply everything by log 3x, I'll get -3 bracket log 3x squared plus 4 equals -5 bracket log 3x, like that. I'll take everything to the right now. So on the right I'll have 3 bracket log 3x squared minus 5 bracket log 3x minus 4 equals 0, which amounts to what you were doing with the substitution anyways, because the reason you were doing the substitution was to make it quadratic. You can all see that this is quadratic. It's quadratic where the variable is log 3x. Now can we factorize this? Let's see. Well, it has to be a 3 log 3x, and the other one has to be log 3x. Now 4 and 1, 2 and 2, 6, no, 4. Do you need the rule? No, I don't know. 4 and 1? You need the rule? No factors?
No factors, yeah.
Okay. So we have log 3x equals minus b plus minus square root b squared minus 4ac. So that's 16, 30, 48, is it? Yeah? Over 6. So that means log 3x equals 5 plus or minus, what's that, 73 over 6. Okay. So do you realise what exactly you're saying here? What you're saying here is 3 to the power of 5 plus or minus root 73 over 6 equals x. Because remember, that's what log means. You're saying 3 to this power will give me x. So that's how we get our two answers. You know, the first answer is going to be 3 power 5 plus root 73 over 6, and the second answer will be 3 power 5 minus root 73 over 6. And we can get our two answers out from that. And both these answers are positive and not 0, so both answers are fine. Now that's a very hard one, but that's the last example. That's the hardest one for today. It's quite an involved question. They're both positives. That's all we ask.
Yeah.
They're positive and not
The
0.
second one positive.
Yeah.
Just double check.
11.9 and 0.5.
11.9 and
11.94 and 0.52.
5.2. HS1, Mahmoud, yeah, so that's okay. Gafar, yeah. Amjad, yeah. Zara, where, yeah. Mo,
Yep.
yeah. Daniel, Sevi, where? There you are. Sabrina, Alfreda, Arya, Chidi, Yung Peng, Amna, oh there you are. Mariam, there. Okay, so that's everybody's in from HS1. Yeah. HS2, Michelle, where? Oh there you are. Abir, yep. Autumn, yep. Celine, yeah. Sophia, yep. Mubarak, where? Oh, there you are, right there. Looking right at me. Chidera,
Yes.
yep. Mohammed, there you are. Sabrina, no? Moza, yep. Angela, Ahmad, Zara.
Yeah.
There. Alright, so just bring it in. Okay, did you write this one down? Yeah. So you can get a start on these questions now for a couple of minutes. First and last, I think, will be necessary here for practice. Now guys, I'm saying first and last, but also you may feel you need to try more than 2 questions from question 6, because you can see in number 6, you know, some of them look a bit different and a bit tricky, and if you don't want to be surprised in the exam, you might feel the need to do more than just 2 in number 6. It depends how familiar and comfortable you are with them. So anyways, at least the first and the last in each one, and you can have a start of them now. My advice in 6 is just look for yourself at which ones look different. Like for example, Angela, if you see do you see T? Yeah. It kind of looks like what I did in D. Yeah. But if you look at, for example, the next one, U, that one's different looking because there's no fraction, and both arguments are linear terms, you know. Yeah. So you wouldn't expect U to be done the same way as T. And likewise, you know, if you were to look at W, yeah, you know, that one's a bit different as well. And also Z, which you're doing anyways. They kind of do, don't they? Amna, do you mind turning the light on, please? Thank you.